Our topic for today is covalent compounds. Carbon is in group 4A. That means that it has 4 valence shell electrons. And 4 is a large number of electrons to transfer. If carbon wanted to satisfy the octet rule, it could gain 4 or it could lose 4. But again, that number 4 is pretty large, and yet carbon forms many compounds. We know also that chlorine, oxygen, and nitrogen like to travel around as pairs, and there'd be very little tendency for nitrogen, these two atoms, for one of them to give up electrons and one to take on electrons. So somehow these compounds as well work out a way to satisfy the octet rule and yet do so without a transfer of electrons. They do it by sharing electrons to form covalent bonds. A typical ionic compound is sodium chloride. It has a metal and a nonmetal, and these two attract each other by an ionic bond, and that's typical of ionic compounds, metal and nonmetal. We have a number of compounds that involve 2 nonmetals. For example, carbon dioxide, that's a covalent compound. And there's quite a difference in the naming of covalent compounds. We indicate how many atoms are involved oftentimes. For example, carbon dioxide, the di, that prefix indicates that there's 2 of these oxygen atoms. If there's only 1 of the first atom, we don't indicate it. In other words, we don't say it's monocarbon dioxide, simply carbon dioxide. It's the name of the first element, the stem of the second element, an IDE ending, and then a prefix to indicate how many of those atoms there are. CO exists, and now we see that why we need to have prefixes to indicate the number of atoms that are involved. If we had named these two like an ionic compound, well, they would have both been carbon oxide, and that wouldn't have been sufficient. This one is called carbon monoxide. 1 of the first element and 1 of the second element. N2O5, well, there aren't too many compounds where we have multiple atoms on the left-hand side. This is called dinitrogen, and then 5 oxygens is pentoxide. Carbon disulfide, hey, here's a good test for you now to see if you can name covalent compounds. An important skill for you to have, H2O. Well, we know that's water, don't we? And we'd never call it anything else. But if we were to give it a more systematic name, using these rules for covalent compounds, we'd call it dihydrogen monoxide. Here are the prefixes that we'd like you to know so that you can name covalent compounds. First 5 would be sufficient: mono, di, tri, tetra, and penta.